So example, calculate for the support reactions of the following beams. So let's start with letter A. So we have here a beam, and then we're going to follow the process. First is write a letter to every change of loading. So from left to right, we're going to assign letter. So from left, you have letter A, and then you have the same loading here, and it ends here, so it's going to be point B here, and then no loading here, so until the right end of the beam. So we have ABC beam. And then next procedure is we're going to draw the free body diagram of the beam. So we're going to draw the beam, and then we're actually just going to copy all the loads of this beam. So let's copy that, or let's draw that. Drawing that one, let's put it here and there. And of course, let's follow. This is a distributed load. So the number of lines here, the vertical lines, doesn't necessarily mean anything. So it just represents that this is a distributed load, and it has a 3 kilonewton per meter nga intensity. So it's 3 kilonewton per meter nga intensity. And then this is the load here, which is 25 kilonewtons. And there. So we're gonna write 6 meters here, and this is 4 meters. And the next procedure is we're going to recognize the supports used in the beam. So for letter A, the support used is a hinge. Therefore, a hinge will give us a force vertical. So I'll just call this as AV, and then force horizontal as AH. So this direction of AV and AH are just only assumption. And then at point C, there is a roller. So you have to provide a translation of that reaction of roller. So you call that as CV. So by the way, do not forget that you have letters assigned A, B, and C here. And then next procedure is to resolve forces when there are inclined forces and distributed load. So in this case, there are no inclined forces, but rather a uniform or distributed load. So for a distributed load, you get the component, the resultant. Since this is a rectangle, we know already that a rectangle's resultant is always at the middle of its distribution. So the distribution is 6 meters. So the resultant is the product of 3, which is the kilonewton per meter, times 6. And that's equal to 18 kilonewtons. And this 6 is, this resultant is found 1/2 of 6. So this is 3 meters on the left, and here this is 3 meters from the right. Okay, so in this case, we are now ready to use the equilibrium equations. So what are the equilibrium equations? You have the summation of force vertical equal to 0, upward positive, downward negative. Then you also have summation of forces horizontal equal to 0, to the right positive, to the left negative. And then last one is the summation of moment at any point. Then that's equal to 0, clockwise positive, and counterclockwise negative. So in the case of summation of moment, actually the thing is you have to always use the point where supports are found. So always rotate at the supports. So since this type of beam gives you two supports, it's at point A and point C, then you get to choose which one you'd like to use. It's either point A or point C to rotate this summation of moment. Okay, let's start. Starting with the summation of forces horizontal equal to 0, to the right positive, to the left negative. So the forces to the right, or the forces to the left, or the forces along the horizontal alignment of this beam is only AH. So therefore, you have to write AH. The direction is to the right, so it's positive. And since there are no other horizontal forces, then you immediately write AH equal to 0. Then this represents now your reaction for AH. Okay, proceed. Let's proceed with summation of moment. So actually, instead of getting summation of force vertical, then you can immediately use the summation of moment. Then you get to choose, it's either point A or point C to rotate the summation. So in my case, I'd like to rotate at point C, and that's equal to 0, clockwise positive and counterclockwise negative. So we're gonna rotate all the forces at this point here. So we have to cancel out CV because it's not a force that will cause moment. Somehow it will just only pass through point C. Okay. So what are the forces nga mo cause of moment? So all the forces that are found away from point C, meaning wala sa point C. For example, although AH is not placed near point C, but actually point or AH will actually just pass through C by principle of transmissibility. So therefore, AH is not included. Anyway, AH is 0. But in case AH has a value, so just remember that any point that will pass through the point of rotation will not cause moment. Okay, so in this case, we only have this AV to rotate. Okay, so how do we know the rotation of AV? So since the force is upward, it's going to rotate the beam clockwise. So it's going to rotate AC with a clockwise direction. So it's gonna push up. Therefore, the beam will move up. So it's going to rotate clockwise in the position of point C. So you have AV clockwise, so that's positive. Then the moment arm of AV from point C is the distance of point A to point C. So the distance of point A to point C is 6 plus 4, or that's actually 10. Next, we have this 25. The 25 is position downward. So it's pushing the beam downward. So it's gonna rotate counterclockwise. The beam will rotate counterclockwise. Therefore, it's negative 25 times the moment arm is the distance of point B where 25 is acting. So point B man ang point of application sa 25. Therefore, the distance of point B from point C is 4 meters. So you're right, 4 meters here. Next is the last one, which is 18. So as you can see, 18 is the resultant of the force distribution. So as you observe that this force here will actually move the entire span or entire beam clockwise, then counterclockwise rather, then therefore this 18 resultant will be considered as negative, and the moment arm is the distance from the resultant of 18, which is here towards point C. So it's actually from this distance padung sa point C mo ni iyang moment arm. So basically, it's the sum of 3 and 4. So that's our moment arm. So it's 3 plus 4 equal to 0. And by that, we may now proceed in simplifying. This is AV times 10 minus 25 times 4 minus 18 times 7 equal to 0. And you get your calculators. Or by the way, let's just transpose this. You have AV times 10 equal to Transposing this to the other side, it will become 25 times 4, and then plus 18 times 7, and then simplifying, you have AV equal to, let's divide everything with 10, so 25 times 4 plus 18 times 7 divided by 10. So now you have AV. So what is our AV equal to? So you just get your calculators, 25 times 4 and then plus 18 times 7 divided by 10. So the answer is 22.6 kilonewtons. So we obtain a positive value because our assumption that AV is upward is correct. Okay, that is our AV. So this time we're now ready to use the summation of force vertical equal to 0, upward positive, and downward negative. So what are the forces? Vertical, you have AV, and AV is upward. And then you have 18, which is downward, so that's negative. And then you also have 25 downward, so that's negative. And the last one is CV, which is upward, so it's positive. And that's equal to 0. So this time, we're going to substitute the value of AV, which is 22.6, then minus 18, then minus 25, then plus CV, and that's equal to 0. Transposing all the constants to the right side, so it's leaving CV equal to 18 plus 25 minus 22.6. So our CV is equal to, just use your calculator, so that's 18 plus 25 minus 22.6. So that's 20.4 kilonewtons. Then we obtain again a positive value because the assumption CV to be upward is correct. Okay, so how do we know that our answers are correct? So basically, since you only use the summation of moment about point C, and we have this condition that you can use the summation of moment about point anywhere as long as you are rotating at the supports. So since we're through rotating at point C, then we may proceed do the checking rotating about point A, just to check you whether you got the answers correctly. So let's do the checking. So let's do the checking here. So checking, we're going to use the summation of moment about point A because again, you're done using the summation of moment C. So why it's point A? Because this is the position of the other support. So summation of moment about point A equal to 0, clockwise positive, counterclockwise negative. And let's proceed. So can I just borrow this one because it's quite far na. Okay, this is the position. So I'd like to have the summation of moment about point A. So by the way, you need not to redraw this anymore, huh? It's just that I am dropping it here because I cannot see it in my screen anymore. Okay, so let's have the summation of moment about point A, and we'll start with CV. CV is upward. CV is upward. Ganina, that AV is upward, it causes rotation clockwise. This time, although CV is upward, it doesn't mean clockwise po siya. Remember that the rotation point is point A. Therefore, the influence of this upward at point A will cause the beam to be rotated counterclockwise. That's why you have CV to be written as negative, and the moment arm is the distance of C from A, and that's equal to 10. Next is 25. So 25 will rotate the beam clockwise. As you observe, the rotation of this 25 about point A, it's making the beam rotates clockwise direction. So it's gonna rotate something like that. No? So mo na yung rotation because the force is downward about point A. Okay, so you have plus 25, and the moment arm is the distance of point B from point A, so that's 6 meters. And then the last one is 18. it's actually clockwise, and the distance of 18 padung sa point A is only 3 meters, and that's equal to 0. So since you have already CV as 20.4, so that's negative 20.4 times 10 plus 25 times 6, and the other one is 18 times 3, we'd now be able to know whether we got our answers correctly or not. So it should be equal to 0, or else then there must be something wrong. So negative 20.4 times 10 plus 25 times 6 plus 18 times 3. Our answer is 0. So therefore, since our answer is 0 equal to 0, then we got all the answers correct. So let's proceed to our next example.